Hi, welcome to another video. So today I'm going to show you how an ideal boiler works. So most gas boilers work in this fashion. So this is an ideal, is an ISAR 24 that's stripped down. And this is the main control unit. It's got two Atmel microcontrollers. First time I've seen Atmel microcontrollers in anything. So that's a control unit. It essentially turns on an ignition module, an HT coil, that produces a nice big healthy spark here, which you'll see. A second or so later this gas valve comes in, so I'll be waiting to see a little flap move down. That's the gas turning on. Then it wants to see the electrical energy from the gas, sort of ionised gas particles. That gives you sort of minus 22 volts down here. You can put a meter on it and you'll get sort of minus 25 volts DC. Just make sure it's connected, otherwise the boiler will sort of time out. So once it sees that electrical energy from the gas flame, that's it. The ignition turns off and the boiler light, a white LED, will come on here. This has actually gone flamed out, so it's the LF means it hasn't seen a flame. Got the water pump here to send the water around the central heating. A few temperature sensors. One's an overheat, and I think there's two temperature sensors to monitor the hot water central heating and hot water out. There's a dry flame sensor there, measures the temperature at the top of the boiler. So that's the water pump. Small heat exchanger here, and that's a diverter valve. Diverts your water from hot water to central heating. Hot water always has priority over central heating. And finally over there in the corner, that's the fan. Once it sees, or once it thinks it's got a flame, the power on this will pick up. One of the main things with these ISAR control units, there's a little transformer inside that burns out on the primary stage, so you can get replacements. I actually repair these as well. Or if you've got ideal boiler trouble, give us a shout. Certainly if you're near South Yorkshire, pop along, I can test your ECE for you. So I tried a small butane lighter, didn't work, so I've got this butane propane mix, and that gives sufficient ionisation for this to pick up enough electrical energy for it to think there's a fire. I have to hold this case so that the energy from here is with respect to ground, and I'm just sitting on the floor, and this probe is with respect to ground. So that's about it. Take some of the mystery out of a boiler. So I'll reset this. Watch for the white light to stay on once it's got a flame, so I'll have to light this. So watch for the spark over here. And that's it, we've got our white light. Hopefully you can see that. Oh, it's gone out, I moved so it's gone out, it's going to try again. Watch for the white light. Too busy talking to the camera and not watching this valve. There it goes. And we've got our white light. The fan should pick up in a minute. I've taken the gas away. See, the light's gone out. Now I'm going to try and reignite. Hopefully you can see that spark. pressurised 3 times. So this is only a metal rod. If you're looking at a boiler, you can check the voltage. So look, voltage DC, with respect to ground. Now in this instance, because my gas flame is not very powerful, so this meter sort of loads that signal up and it doesn't always start. So, but you'll get an idea of the voltage dropping. So that's DC at the moment. You can see that is pulsing. AC, with respect to ground, we've got 209 volts AC, but if I hold this earth and that was hot, it's just floating. So that's important. It's got to be allowed to float. So I can't stick my power supply on it and stick minus 20 volts down it. It doesn't work. I tried a few permutations. So this is ionisation from the gas, from this heat. So I'll give it another go and let you see the meter. Hopefully you can see that reading. Right, so I'll have to light this first, so I'm ready. The ignition will start, then I'll watch for this gas valve to open, then I'll hold the flame up. So if I just do this now, you can see minus 20 volts. That's the thing's turned on, so if I reset this, that's going through its test. Hopefully watch for this white light to stay on. I have to watch for the gas valve to open. See, this meter is loading it, so it will shut off. The gas valve shut off. Gas is on. And that valve's just turned off again, so I'll now get rid of that. And we've got our white light. You see this meter cut it out again, so So on your own boiler, because you'll have a decent gas supply and a decent flame, you will be able to leave your meter on there and you'll get sort of minus 25 volts. But because of this flame, I'm not getting enough ionised radiation into this electrode. We'll call it an electrode, it's just a piece of metal. And I can demonstrate that. So it's just a piece of metal with a ceramic insulator. You don't want any of that energy wasted, so I stick this clip onto there. Now this screwdriver hasn't got particularly good insulation through the handle, so I'll have to put it on the ground, but if I connect that electrode wire to here, sit that there so I'm not touching it, the metal isn't touching this case, so it doesn't, just make sure this electrode's clean. And I'll demonstrate the flame on this screwdriver. Watch for the light to stay on. And we've got our light. Hopefully you saw the white LED comes on, that means the burner is going, and you can obviously hear the fan pick up. That would pick up, get the boiler nice and hot, and look for the feedback on the temperature sensors and maintain that heat that way. If the boiler cools down, the fan would pick back up again, and when it's hot it slows down. So that's how a gas boiler works here in the UK anyway, or UK and Europe. That's how the flame sensor works. It's just a piece of metal, picks up ionised radiation, and you saw that you get sort of minus 22 volts DC on a good system. And to reiterate, I struggle with the electricity because it's just a small handheld burner. Hopefully it's demystified how your boiler works. Pretty simple once you know how. Thank you very much.